Hello all. So you've already watched part one of the video. At least I told you to watch through, I think, like 7 minutes and 40 seconds, up until I gave the answers, and then I wanted you to try it out for yourself. So in part two of this video, I wanted to make sure that we recapped on just solving for number of atoms. So in the previous example with the Legos, just remember that we made up these kind of fake masses here for sodium, magnesium, and phosphorus and pretended that was the mass of a Lego brick. And we also pretended that one brick is 10,000 atoms. And we use that for the analogy of, a mole of sodium coming from your periodic table is equal to 6.02 times 10 to the 23rd atoms, which is equal to 22.99 grams. So what I just want to make sure you're able to do is solve for the number of atoms in something. So let's actually build off of this same problem, but I think what we're going to do instead here is, instead of saying if we have 21.84 grams of magnesium and asking to solve for, how many grams of magnesium phosphate could be produced, what if we just change this and said, if we have 21.84 grams of magnesium, how many atoms do we have? Because again, I want you to see just kind of how these processes build. So it's important to remember that, again, the reason that we even use mass at all is because we can't get down and count atoms. So every atom has a different weight. So what we have to make sure that we do here is you can't go from a mass directly to how many atoms there are. I mean, you can if you fully understand it, but a lot of times when we're starting to understand this, it's actually better to go from mass to moles to atoms. Moles really are the center of everything. So if we were to jump right into doing this, again, we're going to have our 21.84 grams of magnesium. And just like we did last time, if I said that every magnesium is 0.91 grams, you can just go ahead and be like, okay, well, I have grams of magnesium on top. I know that 0.91 grams of magnesium is equal to one brick of magnesium. And so you got to do that same process of figuring out, well, in order to get to how many atoms are there, I need to first figure out how many Lego bricks are there. And I think if we did this, we got an answer of 24 bricks of magnesium. So with that, that's great. And now a lot of you might reason, oh, well, up here we said that one brick is equal to 10,000 atoms. So therefore, if I just continue this one step further, for every one brick of magnesium, there are 10,000 atoms of magnesium. Or, if I asked you a different problem, if we had wanted to go to magnesium phosphide, like in the previous problem, you would have to go from magnesium to magnesium, moles of magnesium phosphide or bricks of magnesium phosphide, and then to atoms. So you just have to get to moles of whatever you want first, and then go to atoms. So, we could follow this, and we can, for those of us that like to cross up our units, we can see all those cancel out. And if you did this, you would get your answer of 24,000 atoms of magnesium. Or if we want to do this in terms of the real chemistry, similar process. We have to get to moles first, and it's pretty simple to do that. I know that 24.31 grams of magnesium is equal to 1 mole of magnesium, because it's the same thing. 1 mole of sodium is equal to 6.02 times 10 to the 23rd atoms, which is equal to 22.99 grams of sodium, or you can just substitute in the mass of magnesium up here. So now this gets us, if you wanted to, we could stop right there and see that this is 0.898 moles of magnesium. But we're just going to keep this going. We don't need to solve for that right away. And we know that 1 mole of magnesium is equal to that, and it's that really large number, 6.02 times 10 to the 23rd atoms of magnesium. This is where, if you're trying to use a calculator on your phone or your iPad, you might have to turn it sideways to get the option to do that. The way that you would do this is you would put in your calculator 6.02 times 10 And a lot of times they'll actually have this like X to the Y key, and that's what you might have to hit in order to put in that raised to the 23. And so if we go ahead and solve for this, by plugging in, we should get an answer of, and again, I had technically 4 sig figs, so I should have, since all I did was multiplication division, I should have 4 sig figs in my answer. So 5.408 times 10 to the 23rd, sorry, let me rewrite that, to 23rd atoms of magnesium. And there we go. That is how you would solve for a mole problem. You just always solve, first just get to moles of what you want. So again, thank you for learning with me. As always, if you have questions, feel free to reach out.